So we have two different terms here. The objective function is an equation and that was the equation that you were using in the 6 problems from the book, where you had C equal to whatever it happened to be equal to. But our objective function is going to be this equation that we're going to use to find either like a maximum profit or a minimum cost, whatever the application happens to be asking us. And that's actually the final part of the problem that we will look at. The corner point principle says the max or min value is from the vertices of the feasible region. And we also call those vertices the corner points because it's kind of the corners of the graph or the boundaries of the graph. So the max or min value will come from one of those corners, one of those vertices, because if it's in the middle, then it's going to give us an average value. But if it's on the edge of the graph, one of those corner points, it'll find the max or the min value for us. So one of the corner points will be a max, one of them will be a min. So the first problem we're going to look at is a multi-step problem. You've got 2 of these to do for homework. We're going to hopefully get through 2 of them in class. We might not get through all of the second, but my hope is that we can get through them. And I also have a sheet for you that kind of goes through the steps so that you know what to think about. So a small company makes animals for a toy store, and they decide to make lions and giraffes. So think when you go to the zoo, and you go up the stairs, the first thing you see is that like zoo stuffed animal craziness that I make sure we never go in. But there's that store as soon as you walk up. There's the restrooms, a restaurant, and then like the store that has all the zoo toys and stuffed animals. So they decide to make lions and giraffes. And when I was in the Columbus Zoo 2 weeks ago, I tell you my girls got to feed the giraffes. They got to feed the giraffes, so we were like, I don't know, a foot away from the giraffe. We weren't allowed to pet them, but they're beautiful creatures. The lions were not really exciting. They didn't have any male lions. They had 3 female lions that were sleeping because they were all tired at that point. So they decide here to make no more than 75 animals and to keep the number of giraffes to no more than 5 the number of lions. So that's a lot of information there. Going back and looking again, we have lions and giraffes. We're making no more than 75 animals in all. And they decide to keep the number of giraffes to be no more than 5 the number of lions. So there's a couple of pieces here. The first part says represent the constraints with a system of linear inequalities. And the other thing you'll be asked to define is what are you using for x and y? And it's already given for you here. So we're saying the x would be the lions, the y would be a giraffe. If you'd rather use an L and a G, you can use an L and a G. But that's kind of up to you how you want to define your variables, but that'll always be part of it. So list the variables you're using and what do they represent in the problem. So when it says represent the constraints, a constraint we said yesterday was a restriction. So see if you can try and come up with a system of inequalities. So how are we restricting the graph? What inequalities would the information in the paragraph give us? So just try and write them down right now. See if you can write a couple down. I have 4. So I've got 4 inequalities. See if you can come up with 4. Jack, you got one. Okay, give me one.
X is greater than or equal to 0.
And then what would the other one be that would pair with that?
Y is greater than or equal to 0.
And why did you say those two?
Because you can't have negative amounts of toys.
Right. So you cannot have a negative amount of any type of physical object. That doesn't exist. These are called our obvious constraints or obvious inequalities. They are contained in every problem that we do that is an application problem. So even though it says nothing about, you can't make a negative number, that of an animal, that kind of goes along with application problems, and they need to be part of your constraints. So that's how I got 4, because those two would be part of my 4. So those will be 2 of them. Nick, how about another one?
X minus 5 is less than or equal to y.
And how did you get that?
Because, or, no, it would be y minus 5 is less than or equal to x.
Which one is it? Sadie, do you want to help them? What do you have? So it says here, the number of giraffes to be no more than 5 more than the number of lions. So let's talk about that last part of the statement. So Peter, the last part, 5 more than the number of lions. How would you write that? Yeah. X plus 5. So 5 more than the number of lions means my number of lions plus 5. 5 more than the number of lions. So the giraffes can't be more than that. So Josh, what would that look like?
Y is less than or equal to x.
There we go. Y is less than or equal to x plus 5. So my giraffes is y. So the number of giraffes is y. It cannot be more than. So if it can't be more than, it has to be less than or equal to. And then the number of lions is x plus 5. So 5 more than the number of lions. Questions with writing that second inequality? Dimitri?
Would y minus x is less than or equal to 5 be the same?
Yes, so because if I take the x to the other side, which is what Sadie said, I think, correct? Yeah. So you could also have y minus x is less than or equal to 5, same exact thing. Because if I had the x and the y next to each other, I'd have to have a negative x. All right, so we have one other piece of information. Nina, what else do they give us up here?
X plus, oh wait, should I say the equality?
Yeah, you're good.
Okay, x plus y is less than or equal to 75.
And how did you get that inequality?
It says to make no more than 75 animals.
Right. So both animals combined, the 2 that we're making, have to be no more than the 75 animals in all. And Nina, that means if I place that in y form, y would be less than or equal to
Negative x plus 75.
negative x plus 75. So we have 4 inequalities. 2 of them were not directly given, but because we are making something, those 2 have to be part of the problem because we can't have a negative amount. So part B wants us to graph the feasible region and find the coordinates of the vertices. It says record these constraints below. We have a little grid, and in this grid, we're going to make our x and y axis. And I'm just going to come down and make it lower. Because our original constraints have to be positive, we don't need to place it in the middle of the graph. Come on, buddy. So you don't need to place it in the middle of the graph because we are not really worried about the middle of the graph. There it goes. So I'm placing them on the edge. And that's because of those 2 original constraints that x and y are greater than or equal to 0. I know that it's not going to be anywhere else on the graph. It's not going to be on the left. It's not going to be down below. Let's So the next thing we have to do is pretty much decide what to count by. My y-intercept has to go up to 75. So a good number to count by for each of the boxes might be what, Jack? 5, yeah. So count by 5. So try and use the same thing. So it makes the slope a lot easier to graph if you're counting the same way on each axis. You don't have to label all of them. Label enough so that you can kind of gauge as to what you're counting by. Sometimes labeling all of them helps you then get those ordered pairs. And then the last thing, any application problem, your axes need to be labeled by what they're talking about. So our x-axis is the lions, the y-axis would be the giraffes. So down here, I'm gonna put lions. And then over here, if I can squeeze it in, I'm gonna place giraffes. You have more room on the edge of your paper. So because it's an application problem, the axes actually represent something. So we need to label the axes with what they represent. And then you're graphing. So the first two that we're graphing are those obvious inequalities that Jack told us, the fact that it has to be greater than or equal to 0. Yes, you need to actually graph them. And I know it's just on top of the x and y axis, but make sure you're graphing your lines. X is greater than or equal to 0, y is greater than or equal to 0. So graph those two. Everything should be above the x-axis and to the right of the y-axis, because x is greater than or equal to 0 means this way, y is greater than or equal to 0 means above. And then graph the other two as well. My Apple TV is not liking me this morning. So see if you can then graph the other two and darken the feasible region. So where is your solution? So you're graphing those other two inequalities. You can use the regular slope. So if it's a negative slope, you're going down one, right one. It's okay that you counted by 5s. Make sure you're plotting enough points that you can see where your lines are connecting. So x is greater than or equal to 0 to the right. Y is greater than or equal to 0 above. The other two are less than. Less than needs to be below. And it almost creates a triangle except for that little piece on the left. So it's actually a quadrilateral graph or feasible region. So make sure you get those 4 ordered pairs. So record the ordered pairs or the coordinates below that create the vertices. And then see if you can answer the last question. The profit on each line is $20. The profit on each giraffe is 18. How many of each kind of animal should we make so that we can have a maximum profit? pairs, what 4 ordered pairs did you come up with? Besides 0, 0. So 3 more. And then the last one, 75, 0. So if you look at the final question, the profit on each lion is $20. The profit on each giraffe is 15. How many of each kind of animal should the company make to have a maximum profit? This last question, we need to come up with a profit equation. So this would be our objective quantity or objective function. So based off of the information, how would we use that to create an equation for an objective function?
P equals 20x plus 81.
Yeah. So the lion is X, $20 for each lion is how I would make money. $18 for each giraffe. So that's going to create your objective profit, your objective quantity. And we're going to make a little T-chart with our X and Y value. Obviously, 0, 0 isn't going to make us any money. But plugging in the other ordered pairs, those 4 ordered pairs, to see which one would make us the most amount of money. So Nina, if we only sold 5 giraffes, how much would that make us?
Oh, $90.
Yeah, probably not enough. Nina, do you have, if we sold 25 lions, how much that would give us?
Yeah, that would give, wait,
Sorry, 75. My fault. 75.
1,500.
Yeah, $1,500. And how about if we sold 35 lions and 40 giraffes?
1,400.
1,040?
Oh,
Is that what you said?
I got 1,400.
1,400?
Yeah.
Sorry, I just didn't hear you the first time.
Almost 20.
I really didn't hear you. Sorry, Nina. Oh, okay, so how many lions and how many giraffes should you make, Nina?
Make 75 lines and 0.
Yeah. Now, would you make everybody happy if you only sold lions? Probably not. So you'd probably have to kind of analyze. It's only a difference of $80. So it might be a better choice to make lions and giraffes. But based off of the information from the problem, we're making 75 lions, and unfortunately, the giraffes get this sort of short change that they don't get any questions. So we're going to start the next problem. I want to at least try and see if we can create the information coming up with the equations, because that's the most difficult part, are inequalities. Can we create those inequalities based off the information we're given? Does anybody have pottery? No? I think those classes are hard to get into. Sometime take pottery. I wish I would have. Mr. Villegas is awesome. A potter wants to make and sell bowls and plates. A bowl uses 5 pounds of clay. A plate uses 4 pounds of clay. The potter has 40 pounds of clay to make these bowls and plates, so he has a total of 40 pounds. And he wants to make at least 4 bowls. So read through it a second time after you read through it the first time. Again, your X and Y are listed. The X would be the bowls, the Y would be the number of plates. See if you can come up with a system of inequalities. So what constraints are on the system? What would the system of inequalities look like? Eva, do you have an inequality?
I have a couple.
Okay, what do you have?
The x is greater than 0 and y is greater than 0.
Okay, so you said X is greater than 0, Y is greater than 0.
And then I have x plus y less than or equal to 40.
Okay,
Which would be y is less than or equal to -x.
okay, so
So that's
before,
just-
this is close.
Okay.
So I agree with the 40, because that's the pounds of clay, but how many pounds of clay does it use to make a bowl?
So it would be 5x plus 4y.
Right, so 5x plus 4y has to be less than or equal to 40. So we have to take the pounds to make a bowl and the pounds to make a plate and include them. Now one of these three needs to be tweaked a little bit more. This one's good. Peter, which one would need to be tweaked just a little bit?
The
Yeah.
Y's here.
Well,
Wait. Wait, there's any change of those? Oh, yeah, the y is greater than or equal to 4.
so it says we want to make at least 4 bowls. What variable represents the bowls? Peter, you're close. What variable represents the bowls? X. So because we need to make at least 4 bowls, this needs to become a 4. So it can't be greater than or equal to 0 because I want to at least make 4 bowls. So that number actually has to start at 4. So X has to be greater than or equal to 4. The Y has to be greater than or equal to 0. There are only 3 this time. This third one, using that information, the 5 pounds and the 4 pounds, because my total amount of clay is 40. So 5 pounds, 4 pounds, less than or equal to 40. So see if you can start to graph that. Again, decide what to count by. Counting by 5s is usually a good option. I actually think this one you could count by 2s and it will fit on the graph. Actually, even less than 2s, because we're dividing by 4. I don't even think you have to count by anything. This one should fit on the graph, just counting by 1s. Make sure you label each axis. So the X would be the bowls, the Y is the plates, and then just label a couple of those to show what you're counting by. So your homework, as I said, it's 2 problems. The actual word problem is in the book. This is kind of the setup that you're going to use. So 7 and 8 in your book on page 126. These are exactly like the problem we just did. So like the giraffes, like this one here. So you're given information, you're defining your variables, you're listing the inequalities, graphing it, and then that bottom part, the objective function. So when you're reading through the problem, make sure you're kind of like that objective function is separate. You don't graph the objective function. The goal of the objective function is to find the solution to the problem. In this case, the solution would be how many bowls or plates should we make so that we have a maximum profit? Questions? So you should have gotten a triangular region for your bowls and plates. Should have made a triangle. Have a fantastic day. Thanks.